Have you ever stopped to think about what's actually powering the stunning graphics in your favorite video game? Or how an AI chatbot can answer your questions almost instantly? Well, it all comes down to one tiny, super specialized chip. Today, we are pulling back the curtain on the GPU, the hidden engine that's literally shaping our digital world.
So what is this little piece of silicon that can render these hyper-realistic worlds and, at the same time, train massive artificial intelligence models? How does it do both?
The answer is right here. It's a massively parallel processor. And that word, parallel, that is everything. It is the secret sauce, the absolute key to understanding the GPU's incredible power.
All right, section one versus many. To really get what a GPU is, we've got to first talk about its more famous cousin, the CPU. You know, the main brain in pretty much every computer.
Okay, think of it like this. A CPU has just a few, but really powerful, really smart cores. It's like having a handful of master chefs in a kitchen. They can tackle any complex, multi-step recipe you give them, but they do it one step at a time, sequentially. A GPU, on the other hand, is like an army of thousands of line cooks. Now, you wouldn't ask them to invent a brand new 5-star dish, right? But if you need 10,000 potatoes peeled at the exact same time, they are absolutely the ones for the job. CPUs handle complex logic, one thing after another. GPUs handle simple, repetitive tasks all at once.
And that brings us right back to that crucial idea, parallelism. This is the GPU's superpower. Instead of taking on a huge problem from start to finish, it just shatters it into thousands of tiny little pieces and gets each of its cores to solve one tiny piece at the exact same time. That's where it gets its mind-bending speed.
So let's see how this superpower works in the real world, starting with the GPU's original job, graphics. To understand how a GPU thinks, we need to look at the process it uses to put those images on our screens. This whole process is called the graphics pipeline. First up, the GPU takes the basic geometry of a 3D object, kind of like a wireframe skeleton. Then, in a step called rasterization, it basically squashes that 3D shape into a flat 2D grid of pixels. Now here's where the magic happens, shading. This is where thousands of those little cores all work in parallel at the same time to figure out the exact color, lighting, and texture for every single pixel on the screen. Finally, it spits out the fully rendered image. And the craziest part? It does this entire thing dozens, sometimes hundreds of times every single second.
But this is where the story gets really interesting. It turns out that this incredible knack for processing thousands of pixels all at once was the perfect skill for something totally different, powering the entire modern AI revolution.
You see, when you strip it all down, a deep learning model is really just a gigantic collection of numbers all arranged in these huge tables we call matrices. And training an AI, well, that just involves doing millions and millions of simple calculations, these matrix multiplications, over and over again. Think about it. That's basically the same thing as applying a color calculation to every pixel in an image. It's a massive, repetitive, parallel job. It was a problem just waiting for a GPU to solve it.
I mean, just try to wrap your head around the sheer scale here. We are talking about thousands upon thousands of calculations all happening in the same microsecond. It's no wonder that AI frameworks like TensorFlow and PyTorch are built from the ground up to run on GPUs. They unlock a level of speed for this kind of work that a CPU just can't even touch.
Of course, not all GPUs are created equal. You've got your basic integrated GPUs, the ones built right into your computer's main processor that handle everyday tasks. Then you've got the big, powerful discrete graphics cards, the kind that gamers and video editors live for. And then, at the very top, you have these massive data center GPUs. These are the absolute monsters, the workhorses that train enormous models like ChatGPT.
Okay, so beyond just gaming and AI, where else does this incredible power of parallelism show up in our lives? Well, the applications are just exploding across pretty much every industry you can think of.
GPUs are in self-driving cars, processing all that sensor data in real time. They're helping doctors analyze medical scans to spot diseases earlier than ever before. They're running incredibly complex simulations to predict weather patterns and model climate change. They are the engines behind the immersive worlds of VR and AR. They guide drones. They enable massive scientific discoveries. And yeah, they're even behind the mining of cryptocurrencies. Basically, anywhere you have massive amounts of data that need to be processed instantly, a GPU is probably doing the heavy lifting.
So let's just boil this all down. If you remember three things, make it these. First, GPUs are all about being massively parallel. Their entire strength is doing thousands of things at once. Second, they are the great accelerator of our time,
speeding up everything from video games to artificial intelligence. And third, they are built for scale. They are the engines of our modern, data-hungry world.
And that kind of leaves us with a really fascinating final thought. From gaming to science to AI, the story of the GPU is really the story of parallelism. And it makes you wonder, as this technology gets even more powerful, what currently unsolvable problems could we finally tackle if we could process everything all at once?